Good morning. I want to take a moment to thank the folks at SEA for asking me to speak today. It's a great honor, and I'm quite excited to share some of the successes we've experienced at Canyon over the recent years. And one of the things that I would like to say is, as an industry, I think it's very important that we collaborate on some of our successes and reach out to one another and help our colleagues. Some would say competitors, I say colleagues. We're in the industry together, and I think it's very important that we do what we can to bring some of the work back to the U.S. We were speaking before of what's happening overseas, and I think that there are tremendous things that can be done here domestically to ensure we're bringing some of that work back to the U.S. and putting our people back to work. So with that, we'll get into the presentation. Again, I'm with Canyon Engineering Products. Let's see. We were established in 1978 as a simple machine shop. We've evolved over the years into providing design, manufacture, assembly, and test of high-tech fluid control components and devices for the aerospace and industrial markets. Our sales are roughly 13 million, and we have about 76 employees. We're growing rapidly, and facility-wise, we're about 70,000 square feet. Key customers, some of them are in the room. We primarily provide hydraulic components. Some of the key customers you will all recognize: PTI, Boeing, Meggitt, Parker, Safran, some industrial accounts, Detroit Diesel, Waukesha, Eaton, Hamilton Sundstrand, UTC are also some of our key customers. One thing that I wanted to look at when I was asked to give this presentation about capturing market share in a shrinking industry is what's happening with manufacturing as far as economics are concerned, and what's happening with the manufacturing share of gross domestic product here in the U.S. And you can see from the 90s all the way down to 2007, you can see a sharp decline in manufacturing as a share of our gross domestic product. And of course, going along with that, when the share is shrinking, we also have a dramatic reduction in the number of jobs in the manufacturing sector. This makes sense because it's following the trend of what's happening economically. Some would argue that we're having productivity gains, and I agree with that thought process. There are productivity gains going on, but at the same time, I think we have lost some of our edge by perhaps not optimizing and becoming more efficient and being more competitive on a global scale. In fact, here's another graphic slide that shows our trade deficits by country, and it's no surprise when we see that we have a $275 billion trade deficit with China. Again, we are facing global competition now, and we need to do things as an industry. We need to collaborate as an industry to bring these jobs back by increasing our efficiencies and thinking outside the box. The old historic models of manufacturing in the U.S., I believe, need some updating. And I'll talk about some of the things that we're doing personally, and I think that the American industry as a whole, not just aerospace, but manufacturing as a whole, should really embrace these concepts. Some of the implications of the changing economic situation. Obviously, U.S. manufacturing is becoming a lower portion of our gross domestic product. Obviously, our jobs are going overseas. In addition to that, low-cost countries are contributing more to the global manufacturing gross domestic product, and it's really shocking when you see the numbers of what's happening in China. They were about 4% of the global manufacturing gross domestic product in '78. Up to about 17% in 2008, and that number is climbing, I can assure you. There's also been a dramatic consolidation in supply chain. I don't remember the numbers off the top of my head that Michael taught us when we went to the workforce development or leadership conference, but I believe it's something in the order of 50% reduction in suppliers in aerospace specifically. And so the bottom line is global competition is our new reality. What can we do as an industry to affect change and bring these jobs back to the US? In my opinion, it really requires a paradigm shift in our manufacturing philosophy. One of the things that I've personally embraced and Canyon has embraced is building quality into the part, as opposed to inspecting it in the traditional manufacturing method. In my opinion, the AQL batch and queue method is costly and wasteful. Number one, we have buildup of inventory. We're shifting lots of 25, 50, 100 pieces over to inspection, and then the inspectors go through the parts, find one bad part, now it's 100% inspection, your inspection costs go up. You have the tendency to build scrap into the part, perhaps some rework. So what we've gone from as far as AQL, we've really gone to a statistical process control model. We all know that it's very difficult to do in a low volume, high mix situation, but we've done it. And there are methods to do it, there are people out there doing it, and I highly recommend that some of you who may be interested reach out and talk to some of the people who have implemented this process. Another thing is that we're measuring to process capability as opposed to measuring to tolerance. Again, a very powerful tool in detecting changes in your process that may occur prior to building an entire lot, which may include scrap parts. Another item is that businesses must become more process-driven. That helps us to become more standard, create standard work, standard processes, and reduce variation, which is also a large cost in manufacturing in our facility, for sure. Next thing, lean implementation. I'll just run through this quickly. Some of you have probably seen this before, but what we've done is we'll establish a family of parts using common materials, similar run times, similar manufacturing processes. We'll establish a control plan, and this is a new train of thought for us. We're actually tying a toolmaker, CNC program, and our inspector together to create a control plan. We're looking at how the part is being made, manufactured, and how we're holding it with the fixturing to create the inspection plan. We're using a tool matrix so that that's standardized and standardized tooling, and I'll explain why that's important here in a moment. From the programming side, we hired a consultant by the name of Eric Saderwaith out of Lean Solutions in Utah. You may know him. Robert's tool has used him quite a bit. We've adopted the same philosophies. His philosophy is run it till it breaks and back it off. And this was like a huge light bulb for Canyon Engineering. For example, we tended to run our machines very conservatively, and in some cases we've increased our runtime, our cutting speed from 500 to 1,500 surface feet per minute, and as you all know, that would result in a dramatic reduction in runtime. We're creating an SPC plan using the CNC develop features to inspect using the program. This is really key. This is something that really helped us reduce some costs, and that is minimizing the number of tools that touch the part. If we minimize the number of tools that touch the part, we are drastically reducing the number of inspection features that we are inspecting. And fundamentally, the way that this is done is if we measure the tightest linear in diameter feature of each tool that touches the parts, by default, all other features are good. This is fundamental. There may be some additions to that or some changes to that on occasion. Another great opportunity for improvement is using form tools. I was talking to the team the other day, and we created a form tool that would cut 17 features. Now, if we use this basic philosophy and measure the tightest diameter and linear on this form tool, we've gone from 17 inspection points to maybe 2, maybe 3. Huge reduction in our inspection time. Next thing to do, last piece of the pie, is to cellularize. We've taken parts that historically we may have used multiple operators, multiple first articles, and we've created a cell where now we're running a part in the horizontal mill, and we've arranged the cell such that all the secondary operations, deburr, hone, and SPC, which is being done real time, is occurring as the part is running. So you can see from the layout that this may have taken 5 operators in the past. Now we've got all secondary operations while the part is running. And so basically, those secondary operations are free of charge because you're doing them within runtime. As far as C involvement is concerned, C has also been helpful in getting us to standardize the tools, standardize work, set out a strategic plan, look forward, look at the things that we need to do to improve over the next few years. We've attended the leadership workshop, created annual improvement plans. We've hired some consultants. We wanted to go on the fast track. We started self-implementing, and we decided, you know what, we feel that this is so powerful, it's worth our investment to hire consultants to help us out. They helped us identify our value streams, and we did our value stream mapping. We created our one-year Kaizen schedule, assigned process owners, and submitted quarterly reports to help ensure that we were on track with our annual improvement plan. Measurable results, this is where it gets really powerful. And these are for parts that I've sent through the cell that I just showed you. I'll only talk about the first part number, but you can see we've gone on the 40181 setup time of 25 hours down to 9 minutes. Runtime, 5 hours down to 1 hour. And let's see, AQL inspection time, 7 hours in the past. Now it's nothing because the AQL is being done while the machine is running. Deburr process time also is done as the machine is running, and the total savings for a 25-piece lot of the 40181 is over 206 hours. Really, really incredible results. For the metrics for the cell parts, on-time delivery was okay in the past, 95%, not within the gold range, but pretty good after 100%. Lead time, 14 weeks in the past. We were going to multiple stations, outside processing, outside for hone, outside for deburr. Now our lead time for that part is 7 days. Quality, around 2,000 ppms in the past. Now coming out at 0 ppm. Parts are good when they come out of the cell. Cost for this part, some of you may find this really hard to believe, but I can back it up with data if anyone wants to see it. 70% reduction in the price of this part. Really fantastic. Number of operators. Before, 5 operators to complete this part. Now we're down to 1. And the opportunity, a lot of people would get nervous, a lot of employees may get nervous saying, oh, wow, what's going to happen to my job? My answer to that is, if we can reduce our costs this much, if we can be this competitive, and in my opinion, this isn't just competitive globally, domestically, this is global competition. If we can reduce our costs this much, you know, I feel very confident in competing with low labor countries. So the bottom line is, if I can do this, I can bring in more work. We can be more competitive, we're going to bring in more work, and we'll have more jobs, and we'll make more money. That's the bottom line. One last thing that I wanted to share with you is our on-time delivery. We haven't struggled with on-time delivery out the door for many years. One thing that we wanted to do was hold ourselves to a higher standard and look at what was happening internally and externally. And you can see from the chart that the top blue line is our delivery to our customer, which averages 98, 99%. And we started looking at a metric in November of last year to see what was happening the last week before shipment. And you can see that we were in the 40% range to our internal delivery schedule. What that means, between the 40 and the 90%, that last week was a lot of chaos, a lot of expediting, a lot of overtime, a lot of hand-holding, just a lot of things that were having to come together at the last minute. Implementing some of the C Tools and metrics, dashboards were huge in improving this metric. And we're very proud. You can see such a sharp increase in our internal delivery schedule, and something that we're very proud of. Lastly, it's important, we've heard this yesterday. Today, I want to touch on it a little bit, and we all have to remember that employees are our most valuable asset. Demi said that up to 80% of workplace errors are process-oriented and not operator-oriented. Ensuring that the employees understand this process or this concept really does create an environment of trust. It opens up the doors of communication. We're communicating from the bottom up now, just from the top, as opposed to just from the top down. We also know that it's critical to have robust processes and standard work, which will provide employees with the tools to succeed. Dashboards I mentioned, a lot of metrics that we're collecting now, and workforce development and lots of training. Let's give them the things that they need to do their jobs, and it's come a long way. With that, I'll close, and thank you for listening.